Okay, why does the Earth have seasons? Remember, that's our question for our reflective journal. And we did the flashlight demos where you discovered the angle with the most intense sunlight was the 90-degree angle. And the angle with the least intense sunlight was the one with the lower angle. And so part of the reason why we have seasons is that sun angle. Remember how, and I have 2 demonstrations in Canvas that will talk about, that show the flashlight demo again. Remember that intensity is equal to energy divided by area. The 90-degree angle, the light was focused. The 30-degree angle, the light was diffuse. It was much more spread out. It was the same source, the same flashlight, which represented the sun, but it was over a much greater area. You're dividing by a bigger area, that means intensity is less. When you're dividing by a smaller area, like with the 90-degree angle, that means intensity is more. Okay, so now we're going to go up to the Barbie demo. Remember, with Barbie standing at the equator, and this is the sun here. And so when Barbie's at the equator, the sun, if you point to the sun for Barbie, the sun is overhead. That means at the equator, they have much higher sun angles, much more intense sun, and so that's why it's much warmer there. Okay? Now, if Barbie's standing on the North Pole, the sun is not overhead. The sun, if I point her arms at the sun, is at the horizon. You know, the land of the midnight sun. When you're way up at the pole, North Pole, or way at the South Pole, the sun barely gets over the horizon. The sun angle is very, very, very small. So it's colder at the poles than at the equator because the sun angle at the poles is never above 23.5 and usually lower. Okay? Okay, so now let's move to the back of that sheet. All right? And remember, as you travel through one orbit, okay, where is the sunlight most intense and least intense? Now let's look here. I've put north on the board. I've got the Earth's axis pointing at north. I'm going to make one revolution around the sun. Remember, the sun rotates on its axis once a day. They rotate, but it revolves around the sun 365 1/4 days. Now let's do one revolution. So right now, here's the northern hemisphere, here's the southern hemisphere. Which hemisphere is pointing at the sun? And which hemisphere is pointing away from the sun? At this point, we have the southern hemisphere pointing toward the sun, the northern hemisphere pointing away from the sun. This would be summer in the southern hemisphere, winter in the northern hemisphere, because our sun angles are much less. Now, let's go counterclockwise, because almost everything in space is counterclockwise. Okay? We've still got the axis pointing at north. Now we're on this side in our orbit. And look who's now currently pointing toward the sun, the northern hemisphere. This would be our summer. This would be southern hemisphere's winter. So, if this was winter and summer was over there, what season is this? This would be spring. When we are neither pointing toward or away from the sun, kind of in a neutral position. So this is what we call the equinox, the spring or vernal equinox right here. Now we get to winter again, summer again. Now we're at another position where we're neither pointing toward or away from the sun. Again, that neutral position. If that was summer and that's winter, then this must be fall. Fall or autumnal equinox. Okay, I'm going to put it back over here where we started. So, as you travel through one orbit, mark on the ball or the globe. We basically just did that, and this would be summer again for the southern hemisphere, winter for us. Okay. At this date, for us, the winter solstice, the 90-degree sun angles are at the Tropic of Capricorn. Okay, and we're going to go through this again. Summertime, the 90-degree sun angles are at the Tropic of Cancer. That's where we are. That's better sunlight for us. That's where there's so much that happens because of it, and we'll be getting into that. Okay. Now, this question says, what if the Earth was tilted 40 degrees on its axis? What would happen to our seasons if it was 40 degrees? Let's point it actually toward north again. If it was 40 degrees, our winter would be much more severe. Our summer would be much hotter. Okay? More extreme, that would be more extreme. If the Earth had no tilt, we'd have a whole different situation as well. Now, the Tropic of Cancer, the Tropic of Capricorn, those are defining the tropics. If you live anywhere between those two lines, and in the middle is the equator, then you live in the tropics. Then at some point during the year, you have that 90-degree sun angle. We in Michigan don't really get above, 72 degrees, okay? Now, let's go into our worksheet. Remember, this is your group lesson together. You're going to turn this in, work on it together, turn one in with everyone's names. Okay, so it says here the first thing that we're going to do. Okay, let's see. Okay. All right. So we're going to go to this simulation here. Okay. Go to the interactive. Now, the question is, what portion of the Earth is lit at any given time during the day? What portion is lit? 1/2. 1/2 of the Earth is lit at any given time. The other half is dark. Okay? So this is talking about what portion of the Earth gets sunlight. So you're going to answer that question here. Okay? Now, it says using the same page, click on all 4 cities and on Tropics and Equator button. So we will do that. We're going to click on all 4 buttons. We're going to show the tropics, the Tropic of Cancer, Tropic of Capricorn. Okay. We're going to select the Earth's tilt. Now, if you want to mess around with the Earth's tilt and see the effect that would have, you notice 12 hours of daylight every day here. If we had 0-degree tilt, look at the temperatures. Okay. But we really have a 23.5-degree tilt. Okay. So the questions on your page say, let's look at the hours of daylight indicated for 4 different cities. And let's look at different times. So you look here is January, 6 hours of daylight. We have about 9 hours in January. Quito, at the equator, 12 hours. You'll notice this 12 hours every single time, no matter what month we click. Australia, 14 hours. They're having their summer. We're having our winter. So you're going to click through this each month, and you're going to record these numbers. Look at on the equinox. What do you notice? If this was actually March 21st, you would see 12 hours, or whatever day the equinox is that year. It all depends on leap year. We had leap year this year because the Earth takes 365 1/4 days to go around the sun. So every 4 years, we have to add a day to the calendar to make up for that extra 1/4. Okay? But look here, you're just going to fill in the chart that's on your paper with that material and answer the questions. Okay? So that's all going to go in this chart here. You're going to answer all these questions here. Now, the next thing is you're going to go to this particular page, and you can see that there's a phases of the moon one if you want to use that when we do phases of the moon. But you're going to go to the sun angle one, okay? And we're going to focus on this line right here that shows 90-degree sun angle, okay? So we're going to focus on this line. We're going to go throughout the year. And the question that you're supposed to answer is, where is this 90-degree angle on the vernal equinox, on the summer solstice, on the fall equinox? So we're going to focus on this line. So this is March. 90-degree sun angle is at the equator. Okay. Everyone on Earth has a 12-hour day. Look at this half. Look at our line of daylight and darkness. They're equal. Okay. They're equal. If you look, if you think about the equinox, everyone on Earth has a 12-hour day. Okay. Now let's go to June. Okay. Let's move this line back up where we were. And where do we get that 90-degree sun angle in June? At the Tropic of Cancer. Now remember, this is because the Earth has that tilt on its axis. Okay? The Tropic of Cancer. You're going to write this in on your page. Let's go ahead to September. Where do you think it's going to be in September? It has to get all the way to the Tropic of Capricorn, so guess where it's going to be back at in September? It's going to be back at the equator. Fill in your sheet using this information. Now we're going to go all the way to December. Again, we're going to move this back to the 90-degree angle at the Tropic of Capricorn. Remember, because the Earth is tilted, that is why we have seasons. It's the tilt on the axis, it's the place in the orbit, those two things. So when you do your reflective journal, you're going to answer that question. Okay. All right, our last thing on this sheet is this. Now, this is the same diagram that I put in class. Okay, this is the same I put up in class. So that is your fourth thing. I want you to put that in this page. Thank you.